Hello everyone. Welcome back to Sally and Bytes. Today, we're diving into something we use every day but rarely think about, how the internet works. Have you ever wondered how clicking a link instantly loads a website? Or how you're watching this video on YouTube right now? How does a simple tap on your phone connect you to the entire world? Well, that's the magic of the internet. What is the internet? The internet, short for interconnected networks and often called the net, is a global system that connects millions of computers and smart devices. It enables people to communicate, share information, and access digital services like email, websites, social media, and video streaming. Think of it like a postal system. When you send a letter, the postal service ensures it reaches the recipient. Similarly, the internet transmits emails, messages, and videos as digital data, delivering them instantly across the world. Let's see the examples of the internet-connected devices. Smartphones, laptops and tablets, smart TVs, wearables, gaming consoles, IoT and smart home devices, AI-powered gadgets. Before we dive deeper, let's understand networks. A network is a group of connected devices, like your phone, laptop, or even smart TV, to communicate and share resources. It can be as small as a home network or as vast as the internet. Any device that is connected to a network is known as a node. Let's say you have 6 computers, and you want them to communicate with each other. For example, computer 1 needs to communicate with computer 6, or computer 2 needs to connect with computer 4, and so on. This is where a network switch comes in. A switch allows multiple computers in the same network environment, such as a home or office, to communicate efficiently. Each of these 6 computers connects to the switch using Ethernet cables, enabling seamless data exchange within the network. A switch cannot use wireless technology. If you want the devices in the same environment to be connected to each other over wireless technology, you should use an access point device. By using the switch device or access points, we can create a network called the Local Area Network, LAN. LAN is a network that connects devices within a limited area, like your home, school, or office. It ensures fast communication and resource sharing. A switch device has multiple ports, which are also known as LAN ports. Similar to switch LAN ports, there are LAN ports on the back of desktop computers and on the sides of laptops. To establish a connection between a computer and a switch, we connect the LAN port of the computer to the LAN port of the switch using an Ethernet cable. Once connected, computers can communicate with each other through the switch. You can specify the type of Ethernet cable used, such as twisted pair cable, for example, Cat5e, Cat6, Cat7, commonly used in LAN connections. Fiber-optic cable, used for high-speed networking and longer distances. Now let's see how the switch works. A switch is an intelligent network device. For example, suppose computer 1 wants to send a data packet to computer 4. The data packet starts from computer 1 and enters the switch. The switch then learns and stores the MAC addresses of connected devices in a table, mapping them to their corresponding port numbers. If the switch has already learned computer 4's MAC address and its associated port, it directly forwards the packet to the correct port, computer 4. What is a MAC address? A MAC, Media Access Control, address is a unique identifier assigned to a device's network interface card, NIC. It helps in communication within a local network. It is 12-digit hexadecimal number. For example, 00:A0:C9:14:C8:29. It is used by switches to forward data packets to the correct device in a LAN, local area network. Network interface card is a hardware device that connects a computer or network device to a communication network. It contains the MAC address and helps devices send and receive data over a network. It is either wired, Ethernet, or wireless, Wi-Fi adapter. Now, how will you connect these computers to the internet? A switch alone cannot connect directly to the internet. It needs a router to manage external connections. The switch is connected to a router via an Ethernet cable. Router connects to the internet. A router is different from a switch as it routes data packets to other networks, not just local computers. Routers are common in homes and businesses as they enable communication with other networks, including the internet. This is a basic home network diagram which illustrates how a router with a built-in modem and access point connects devices for internet access. Router-modem combo is a single device that combines the functions of both a modem and a router. Modem's function is to connect to your internet service provider, ISP, and converts internet signals into a usable form. Router's function is to distribute the internet connection to multiple devices via Wi-Fi or Ethernet. Wi-Fi, wireless fidelity, is a technology that enables wireless communication using radio waves. The benefit of modem-router combo device reduces the need for separate devices and simplifies network setup. This is an advanced home network diagram represents a more complex home network setup. Unlike basic home networks, it includes multiple switches and access points for better coverage. Access points, APs, ensure stable wireless connectivity across different floors. A switch is used to provide stable wired connections. The switch connects a computer, printer, and house camera for reliable internet access. This setup enhances both wireless and wired network efficiency within the home. Your router acts as the gateway to the internet. You should choose routers with built-in security features such as WPA3 encryption, firewall protection, and automatic firmware updates to keep your network secure against potential vulnerabilities. Let's see how we are connecting to the internet. A special cable from the ISP is provided to homes and offices, enabling internet access. An ISP, Internet Service Provider, is a company that supplies internet access to users. When you pay for an internet plan, your router connects to the ISP's network, allowing access to websites, videos, and online services. There are many ISPs worldwide. These are the popular ISPs in India and the USA. Now, what does the internet represent? Connecting to the internet means establishing a connection with another computer anywhere in the world. Now let's see this scenario. Here a user from India LAN 1 connects with the user of USA LAN 2. You can see many routers on the internet. The internet is the global network that connects all local area networks, LANs. Millions of LANs are connected to the internet. Routers on the internet are widely distributed to manage and direct data traffic efficiently. Why are there so many routers instead of one? If the internet uses only one router, it will overload the router. LANs located very far from a single router require very long cables. Multiple routers ensure efficient data flow, reduce congestion, improve reliability, and connect networks worldwide. Even if a few routers fail, the internet continues to function properly as the load is balanced in a distributed system. On the other hand, if there is one router, and if the router is broken, the whole internet crashes down. By looking at this visual, you can better understand what the internet is. It shows the cables connecting different countries and continents. These cables are crucial, especially for communication between countries separated by oceans. The colored lines represent underwater cables. To view the cable map of your location, you can check it out at the following link. Thanks to these cables, different countries can communicate with each other. As of early 2025, there are over 600 active and planned submarine cables worldwide, spanning more than 1.48 million kilometers. Some of these cables extend up to 27,000 kilometers, such as the fiber-optic link around the globe. If one of these cables breaks, it could disrupt the internet for an entire continent. It happened such an event in the year 2018. The African Coast to Europe, ACE, cable was damaged off the coast of Mauritania, causing a major internet blackout across West Africa. Some regions were affected for days. You can see the remotely operated vehicle, ROV, here, which is used to repair undersea cables. 2007 pirate attack. Pirates off the coast of Vietnam stole sections of undersea fiber-optic cables, disrupting internet services for weeks. This affected international communication and highlighted the vulnerability of submarine cables. Shark damage. sharks have occasionally bitten undersea cables, mistaking the electromagnetic signals for prey. To prevent this, cables are now reinforced with protective layers. Anchor damage. Ships' anchors accidentally drag and damage undersea cables, causing significant outages. In 2008, an anchor cut cables near Egypt, disrupting internet services in the Middle East and India. Fiber-optic cables carry data underground and underwater at high speeds using light signals. They transmit information much faster than traditional copper cables and are essential for global internet connectivity. Imagine you're in India, video calling a friend in the US. Your voice and video travel through undersea fiber-optic cables that run across the ocean floor. These cables use light signals to send data at nearly the speed of light, allowing smooth and fast communication across continents. The internet can also be transmitted wirelessly using satellites in space. This is useful for remote areas where fiber-optic cables are not available. However, satellite internet can have higher latency because data has to travel much longer distances. Mobile networks, 3G, 4G, 5G, provide internet access to smartphones anywhere. Starlink, developed by SpaceX, is a satellite-based internet service that aims to provide high-speed internet anywhere on Earth. Unlike traditional satellites that orbit far away, Starlink satellites are much closer, reducing lag and making the internet faster for rural and remote areas. With Starlink, we're moving toward a world where internet access is available everywhere. There are 3 levels of Internet Service Provider, ISP. Tier 1 ISP, Tier 2 ISP, and Tier 3 ISP. A Tier 1 ISP is the highest level of ISP that forms the backbone of the Internet. These ISPs own and operate the global Internet infrastructure, including undersea fiber-optic cables and high-speed networks. They have full global access. They don't have to pay anyone for internet access. They use peering agreements with other Tier 1 ISPs. They have direct connections between continents via undersea cables. Provides internet to Tier 2 ISPs. Example, AT&T, USA, Level 3 Communications, USA, Tata Communications, India, NTT Communications, Japan, Deutsche Telekom, Germany. Tier 2 ISP is a regional provider that buys internet access from Tier 1 ISPs and sells it to local ISPs or businesses. Pays Tier 1 ISPs for global internet access. Covers a region or multiple countries. Acts as a middleman between Tier 1 and Tier 3 ISPs. Example, Airtel, India, BSNL, India, Comcast, USA, Vodafone Europe. Tier 3 ISP is a local internet provider that buys access from Tier 2 ISPs and provides internet directly to homes and businesses. Provides last-mile internet access, delivers internet to your home. Pays Tier 2 ISPs for connectivity. Focuses on local users, cities or towns. Example, ACT FiberNet, Chennai, India, GeoFiber, India, Hathway, India, Cox, USA. The Internet Service Provider, ISP, is responsible for the transmission of the data packets from one location to another. Now look at this scenario. We have learnt there are a lot of routers in the Internet. For example, Global ISP has lot of routers, Regional ISP has lot of routers and Local ISP has lot of routers. Each ISP is responsible for specific routers. Imagine you are sitting at home in Chennai, India, and sending a WhatsApp message to your friend who lives in Los Angeles, USA. Your phone connects to your home router, Wi-Fi. This Wi-Fi is provided by a local ISP, Tier 3 ISP, like Airtel, GeoFiber, or BSNL. Your data is converted into small digital packets and sent to your ISP's nearest point of presence, POP, a place where data starts its journey. POP is the local access point for an Internet Service Provider, ISP. Just like when you send a letter, you first drop it at the nearest post office. Here, your local ISP is like that post office, making sure your data gets sent to the right place. Connecting to your local ISP, Tier 3 ISP, Chennai, is completed. Now, we are entering the Regional ISP, Tier 2 ISP, India. Your local ISP, Tier 3, does not have a direct connection to the USA. So, it hands over your data to a regional ISP, Tier 2 ISP. This ISP manages larger cities and regions, handling more traffic than a local ISP. Your data now reaches a network access point, NAP, in Chennai or Mumbai, where multiple ISPs exchange traffic. Think of this as a train station in Chennai, where local trains, Tier 3, bring people, and bigger express trains, Tier 2, take them to major cities. Now we are connecting to a global ISP, Tier 1 ISP, International Undersea Cable. Your message needs to travel from India to the USA. A global ISP, Tier 1 ISP, like Tata Communications or NTT Communications, picks up your data. It sends your data across the undersea fiber-optic cables connecting India to the USA. One of the major cables connecting India to the USA is the SEMEWE5, Southeast Asia, Middle East, Western Europe 5, and the Faster Cable System by Google. Imagine putting a message in a bottle and throwing it into the sea. The ocean currents, undersea cables, carry it safely across the world until it reaches California. Once your data reaches the USA through undersea cables, it is received by a Tier 1 ISP in America. This Tier 1 ISP, like Lumen Technologies, Cogent Communications, or AT&T, sends it to a regional ISP, Tier 2 ISP, in California. The regional ISP manages internet traffic for cities like Los Angeles, San Francisco, or San Diego. Think of this step like an airport in California. Your package, data, has landed, but now it needs local transport to reach the exact address. Now, your message needs to reach your friend's phone in Los Angeles. The regional ISP, Tier 2, hands it over to a local ISP, Tier 3 ISP, like Comcast, Spectrum, or Verizon. Finally, the data reaches your friend's Wi-Fi or mobile network and appears on their WhatsApp screen. It's like a delivery guy bringing your Amazon order to your doorstep. Your local ISP is making sure your data gets exactly where it needs to go. And all of this happens in just a few milliseconds. In your home, the router is like a traffic manager for the internet. It gets one special internet protocol, IP, address from your internet company, called the ISP, which connects your whole home to the internet. Inside your home, the router gives local IP addresses, like 192.168.1.2, 192.168.1.3, etc., to each device, your mobile, laptop, computer and printer. When your devices talk to each other, like sending files between two computers, the router uses these local IPs. But when you go online, like opening a website, the router sends your request using the public IP address it got from your ISP. Let's explore what happens from the moment you open your browser to when you get search results. Everything begins from the client. A client is any device that connects to the internet to request information, like your phone, laptop, or smart TV. When you type a web address like www.google.com, which is called a URL, Uniform Resource Locator, your device asks your internet service provider, ISP, to find that website for you. It's like asking, hey, where can I find the Google website? But just like entering a contact's name in your phone doesn't instantly call them, you still need their phone number. Your browser, like Google Chrome, Mozilla Firefox, or Safari, also needs to convert the web address into a format the internet understands. The web address you typed goes through your ISP, which contacts a DNS server, domain name system, to find the matching IP address for the website you want to visit. The domain name system, DNS, is like the internet's phonebook. It converts human-friendly web addresses into IP addresses that computers understand. Every website has its own IP address, which helps your browser find and load the correct site. DNS translates the text-based domain name you type into the browser into the number-based IP address. For example, when you enter www.google.com, the DNS finds its real address, something like 142.250.190.14. Imagine you want to send a letter to John in New York. But you need his exact address to deliver the letter. DNS does this for websites. This IP address may vary depending on your location because Google uses multiple servers around the world, called CDNs, content delivery networks, to speed up access. Now that we have Google's IP address, we need a system to send and receive data reliably. That's where TCP/IP comes in. The Transmission Control Protocol and Internet Protocol is a set of rules that allows computers to communicate over the Internet. The browser establishes a TCP connection with the web server using the IP address it got for it. Now, your browser sends a HTTP request to the server, for example here, Google's server, to fetch a copy of the web page. This request is sent using TCP/IP. TCP, Transmission Control Protocol, breaks your request into small packets and ensures they are sent and received correctly. IP, Internet Protocol, determines the best route to send those packets across the Internet. Now that we have Google's IP address and our request is broken into packets, we need a place to process and store the website's data. That's where servers and data centers come in. A server is a powerful computer that listens to client requests and sends back data. Servers are housed in large data centers around the world. Example, when you search for something on Google, your request is sent to Google's data centers, which quickly process your query and send the results back. Think of a server as a librarian, and a data center as a giant library filled with books, web pages. When you ask for a book, a website, the librarian finds and hands it to you. Now, let's see how the data reaches back to the client. Once the server processes the request, it sends the response back through the Internet using TCP/IP. The web server sends data packets back to your device. These packets follow the fastest route, they might take different paths. When all packets reach your device, TCP reassembles them in the correct order. Your browser displays the website on your screen. Let's see the difference between the Internet and the World Wide Web. The Internet is a huge network of computers and devices all over the world. Imagine a giant web of wires, satellites, and routers connecting millions, actually billions, of computers. Through this network, we can send emails, download files, make video calls, and yes, even browse websites. So in short, the Internet is the infrastructure. It's the backbone that connects everything together. The World Wide Web, or simply the web, is just one part of the Internet. It's the part that contains websites and web pages. When you open a browser like Chrome or Safari and type a web address, like www.google.com, you're using the World Wide Web. It works using a protocol called HTTP, and it allows you to browse, read articles, watch videos, and do online shopping, all using web pages. Imagine, the Internet is like a huge system of roads and highways connecting cities and towns. The World Wide Web is like the cars and buses traveling on those roads. Who owns the Internet? No single person, company, or government owns the entire Internet. The Internet is a global network made up of many smaller networks. It is maintained by multiple organizations, companies, and governments working together. Let's see the physical infrastructure. Who maintains the Internet? The Internet is not a single entity but a collection of millions of computers, servers, and cables worldwide. Undersea cables and fiber-optic networks owned by private companies like Google, Meta, AT&T and Tata Communications, Internet service providers, ISPs, companies like Airtel, Verizon, Comcast, and BSNL provide Internet access, network exchange points, and apps, places where ISPs connect and exchange data, managed by various organizations. Example, when you send a WhatsApp message, it travels through undersea cables, fiber-optic lines, and data centers owned by different companies. Who controls the Internet? Organizations managing it. Even though no one owns the Internet, several organizations help maintain and regulate it. ICANN, Internet Corporation for Assigned Names and Numbers, manages domain names, for example, .com, .org, and assigns IP addresses. Without ICANN, we wouldn't have human-friendly URLs like www.google.com. IANA, Internet Assigned Numbers Authority, assigns unique IP addresses to every device on the Internet. IETF, Internet Engineering Task Force, develops and maintains the technical standards, like TCP/IP, that keep the Internet running. W3C, World Wide Web Consortium, sets rules for web technologies, like HTML and CSS. Local governments and companies. Governments regulate Internet access and censorship in their own countries. Companies own data centers, undersea cables, and cloud servers. Can the Internet be shut down? Technically, it's very difficult to shut down the entire Internet because it's decentralized. But governments can block access in certain regions by controlling ISPs, example, China's Great Firewall restricts many websites. Cutting submarine cables, which could cause temporary disruptions. Blocking websites and apps at a national level. The Internet belongs to everyone. The Internet is a shared global network. No single person or company owns it completely, but different organizations, companies, and governments manage parts of it. To use the Internet safely, always use strong passwords, avoid sharing personal information with strangers, don't click on suspicious links, make sure websites start with HTTPS, and keep your software and antivirus updated. Being alert and careful helps protect your data and keeps your online experience safe. Thanks for watching. If you found this video interesting, don't forget to like, share, and subscribe to Sally Ann Bytes. See you in the next video.